Hello, I'm George Malin, the editor of Vanilla Plus, and welcome to today's webinar. The subject today is the role of service assurance in hybrid and NFV networks. And I'm delighted to welcome a distinguished panel of speakers today. We have with us Anssi Tauriainen, the Director of Business Development at EXFO, his colleague Ihab Mana, a solution architect also at EXFO, and Mark Mortensen, the lead analyst with Analysys Mason. I'll shortly be handing over to Mark for his presentation, but before I do that, I'd like to start with an audience poll. So here is our first poll of today. There will be two. The first question is, how would you categorize your organization's service assurance strategy for hybrid and NFV networks? And the options are, it is ready, we are well underway in the process, we have just started, we are still in the learning phase, and we have no plans. So I'll reiterate the question, which is, how would you categorize your organization's service assurance strategy for hybrid and NFV networks? And the possible answers are, 1, it is ready. 2, we are well underway in the progress. 3, we have just started. 4, we are still in the learning phase. And 5, we have no plans. While you're responding to that, I'll just give a quick reminder that you can ask questions for me to put to our panel at the end of their session today. So do feel free to use the panel on your screen and take the opportunity to ask any of the panel any question you would like. Thanks very much. I think we're now ready to see what the poll results have been. And the overwhelming answer is we are still in the learning phase, which is good news for today's event, where we're hoping to provide some education. So I think that's probably the standout thing, looking that most organizations are still learning. About a quarter have just started. 15% are well underway in the process, so that's very encouraging. And it is ready, just 10%, balanced out by those an equal 10% that also have no plans. So thanks very much for taking the time to answer that survey. And without further ado, I will hand over to Mark Mortensen from Analysys Mason. Mark, over to you.
Thanks very much, George. This is Mark Mortensen. I'm an analyst here, actually research director at Analysys Mason, and I'm here to provide the analyst view, kind of the high-level view of what's going on here in the service assurance space as we move towards this evolving hybrid network that is going to be made up of both physical and virtual devices. So the abstract you've seen. And first I want to just say that what we're basically talking about here, of course, is in this chart, you see the physical network on the lower right-hand side, and that's there, and it's going to be there for a long time. We certainly anticipate that some of the very specialized devices are not going to be virtualized for the large extent and for another 10 to 15 years. And for at least 20 years, we do expect a lot of physical equipment to be in the network that is eventually going to be virtualized. Of course, there always will be some physical network. You do actually have to move photons from one place to another or electrons from one place to another. But almost all of the high-level functions here, the service functions, we will be eventually virtualized, run in a standard data center on standard hardware. Even if it's run a little bit less efficiently, the business case says that it's going to be a lot cheaper overall to run it as a virtualized thing. So the job of service assurance has always been to look over the physical network, make sure that all the piece parts are working. That's kind of like number one, fault management. Make sure that the services are working, service management, and really making sure that end-to-end the services are really working from the customer's perspective, often called service quality management or overall service management. And that jobs are still the same, other than those first two functions will be done in a very different way by other software, network orchestration software, and virtual managers down below in the architecture. But you're going to find the big job is still going to be to make sure that the services are providing the right quality from end to end, and we'll see that in the presentations that follow, including mine. So there are a number of new functions that are going to be necessary here, and we're showing off to the right-hand side software revenue that we project for service assurance worldwide, and the numbers you see are pretty large numbers. We're talking, in 2014 we were talking almost $7 billion. We do see, you see the small numbers above, the 2313 and 2014, we see as analytics, which is being used for service assurance and some other things too. But this is the service assurance piece of it, which will be growing tremendously also. And then the virtualized next generation OSS, much of which is service assurance on the top here, growing, you see, to be almost $1 billion industry by about 2019, 2020. So we're talking, although a small fraction of the total service assurance market, we are talking about some fairly large numbers here in the market. So if we look at kind of evolution that has to be done, we find that the service assurance for the virtualized next generation network that we call VNGN are going to have to do a couple things. It has to support the services that go across the physical and virtual networks, which are going to be most of the services. It's going to have to provide some kind of unified monitoring for the virtualized part of it. And it's going to have to somehow be the infrastructure here for the overall closed-loop process of automation. Because these services, these next-generation elements are going to be created and destroyed very, very quickly. We're talking about creating and maybe destroying something in 30 seconds to 2 minutes, creating it. Maybe it's only going to live for a short period of time, and then it's going to go away when it's no longer needed. But during the time that it's there, it is a piece of the service, and it's going to have to be monitored for service quality the same way we measure everything else. So we're talking about the requirement here to have things moving very, very quickly in very real time. As we look at it then, kind of the three things that are needed to make these things move very, very quickly are primarily, by the way, there's many, many aspects to it, but these are the primary ones. The first thing is going to be, and I'm going to talk through each one of these in a moment, is kind of a common network topology that is going to be shared from two different sides, things that are today quite separate. Mostly, actually, by the way, on the kind of service assurance side and the service fulfillment side. So those have been two views of the network that have been quite disparate in the past, operating in different databases, operating often with different data models, and just operating completely separately in different organizations. And we're going to be finding the need to have a common network topology, in fact, really a single network topology model and service model, and probably a single database with appropriate caching of information on the two sides for performance reasons. So we'll talk about that in a moment. We see it also becoming an integral part of something that service assurance has nothing to do with today, and that is the order-to-cash process. When a customer order comes in and then it's fulfilled, and then charging starts on that. Now, how does service assurance fit in there? We'll talk about that in a moment, but also plan to provision, which is when you do network additions, and I'll talk a little bit about that in a moment. And in all of this, it's going to become much more real-time and automated. So let's step through these for just a moment here. First of all, we're going to have this common topology model. Like I said, today you'll find a network inventory database usually associated with service fulfillment. It keeps track of what the network looks like and keeps track of what the assignable entities are that are assigned either to customers or to functions. It also usually keeps track of what equipment is being used by what customer. It is also usually keeping track of where that equipment physically is located, so that you can actually go and fix it or do whatever you need to do to configure it. So it's really that whole thing, that physical up through the logical, up to the customer side is there. Now on the that's over the service fulfillment side, and kind of the service fulfillment people own that database. On the other side is the database that lives in that's owned by the people who run the NOC, the Network Operations Center, and they are, or in case Service Operations Center, if you're forward looking. In that case, that is a database that is keeping track of much of the same information. Oh, it doesn't so much care about assignable entities. Well, that's not true. It needs to know what customers are on there. It doesn't really need to know exactly where it is. Well, that's not true, because that's you actually do have to go and fix it eventually too. So in fact, you find that almost all the data in that database is exactly the same as what's in the inventory database on the other side, often in a different format, somewhat in a different structure for fast retrieval, but duplicating much of it. So, except in the most advanced cases, I only know of 3 or 4 cases in the operators where they have actually brought together these two sides, the service fulfillment and the service assurance, into a single database structure. I only know about 3 instances of that being done, and done quite successfully, by the way. But what we're going to find also is that data is going to have to be shared amongst all of the other OSS and orchestrators also, because there are going to be a number of orchestrators at a number of levels, from service level orchestration down to the VNF orchestration. You call it network orchestration, and they all are going to have to know what the network topology is. Okay, so all of these are going to have to be feeding off this database, and it's going to have to be pretty fast also. In fact, it has to be very dynamic, because remember we said that these virtualized network functions might appear in 30 seconds. Wow, that's a whole different time scale than we're used to. Usually these kind of inventory systems were changed at maybe the day level, or maybe a few hours. Instead, we're talking about these things changing and things coming and going in the databases very quickly. So we do anticipate the need to go to some new technologies there, and some new structures in order to get that kind of speed out of this, as well as, if you think about it, all of these different functions feeding off the same data, which can't be heavily cached. It has to be pretty centralized in order to operate at these kinds of real-time speeds. We're talking about some fairly substantial technology in the future. So is that a piece of service assurance? Well, in a way. Is that a piece of service fulfillment? In a way. It's kind of a new construct that we're going to find being required. The next thing is it's also going to become a part of the order to cache and the plan to provision process. What we find, order to cache plan to provision is easier to understand. So today, you plan a network addition, and then you eventually order the equipment. The equipment eventually comes. It gets installed. It gets tested. It gets put into the service assurance database, and by the way, the service fulfillment database also. Usually, these things take weeks, months. Probably not a year, but often weeks and months, and it kind of takes a few days to get these kind of data done. We're talking now, of course, about, first of all, network additions and new elements appearing very quickly that are needed for capacity purposes. And we're also talking about creating new services very quickly. The whole idea of this virtualized network is actually not to save money as much as it is to try and get very quick speed associated with new service introduction. AT&T decides, for instance, as they did just recently, to go into the business of providing a virtual firewall. So they put it in, and they get the specs, they get the software in there, and they can fire that up very, very quickly for a customer. And so that is a piece of equipment, if you will, that's being fired up very quickly during a plan to provision thing, and then available for assignment. We've never had to do it at this kind of speed here. So we find that it becomes service assurance becomes part of this whole plan to provision. When a new service goes in, new elements go in, they have to be put in the database and have to be done very, very quickly. Now, order to cache is a very similar situation where you might be creating a new element for a specific customer that's dedicated to them. Firewall is actually a better example of that than it was for plan to provision, where a firewall would be created for a particular customer premises, but it would be created in the data center again. And that becomes something that has to be monitored for faults. Well, actually, those are taken care of pretty much down with the NFV managers, but it does have to worry about the service level. And so you have to worry about that end-to-end performance of the service level. So it becomes something new. It gets involved, and if for those of you who are big TMF folks, you realize that the ETOM is going to have to change in the plan to provision and the order to cache and a number of other areas. But these are the two primary ones. The third one is going to be there's going to be a lot of changes in here that are necessary, mostly having to do with automation. And we do see that stepping through over time. And this gives kind of our view as to what the changes are, how the changes are going to sequence roughly as we get more and more sophisticated in our service assurance of these virtual elements and these the physical network, and overseeing both of them, the services that go over both of those. As we're doing a lot of these things, you realize we're doing some fairly sophisticated data crunching of an awful lot of data. So this is going to be requiring big data techniques, and it's going to be requiring the kind of analytics that a number of the service assurance and other companies are implementing right now. And I think you'll hear a lot more from EXFO about the analytics piece of this and the importance of it. So let's kind of recap. What are we talking about? We're talking about service assurance. This is an old area that we kind of have known about for a long time. And the last thing that got exciting in service assurance, honestly, was probably the probes, which was deep packet inspection probes. Now we're going to be creating and destroying deep packet inspection probes. We're going to be creating and destroying new elements here, and we have to keep watch over every one of these things to make sure that the service to the customer is being provided properly and in a timely manner also, and giving the kind of performance that the customer needs. So that service quality management that is so important to the customer experience is going to form the basis for all of this service assurance of the future. That is really what I had to say here. I'll turn this back to, are there any questions, please get to me, or to my colleague Anil Rao, who actually did a lot of the research that I presented today. I'm going to turn this back to George now.
Thanks very much, Mark. That was a great presentation. Next up, we have our second poll question of the day. So I'll read that out to you now. And the question is, you, as an industry expert, have probably heard and read many NFV presentations already. How well do you think the forming ecosystems match to your plans and expectations? And the options are, 1, the match is very high. 2, I believe I can find what I need if I keep looking. 3, key pieces are still missing. And 4, I mostly disagree with what I've learned so far. So I'll read the question again. You, as an industry expert, have probably heard and read many NFV presentations already. How well do you think the forming ecosystems match your plans and expectations? And the responses are, 1, the match is very high. 2, I believe I can find what I need if I keep looking. 3, key pieces are still missing. And 4, I mostly disagree with what I've learned so far. And while you're answering, I'll just issue a reminder that you can ask all of our panelists questions today, so please do so in the panel on your screen. Thanks very much. I think we're ready now to see what the results of the poll are. And that's encouraging. There's some faith that the solutions can be found if you keep on looking. So that's good. More worrying, though, is that a third of respondents feel that key pieces are still missing, and I guess most of us think that's probably a consistent view with the state of play in the industry at the moment. An early stage, and there's lots of innovation going on. So that's been a very interesting poll. Let's move on and introduce our next speaker, who is Ihab Manna, the NFV solution architect at EXFO, and he'll be followed by Anssi Tauriainen, also from EXFO. But I'll hand the floor over now to Ihab. Ihab.
Thank you very much. Thanks, everyone, for attending the webinar. And I would like to start by showing our vision in EXFO and how we see this is progressing. Of course, we all agree on the end goal, which is basically creating services quickly and monetize them and increase the revenue and shorten the life cycle of creating new services and enable innovation. But in this slide, I really would like to really show how we're going to get there, because there is a set of challenges to progress to that point, and also a set of innovation that is required to, or are required to get us there. So we see the first step as virtualization, and it's really the step of, after building the cloud, is how we move physical function that makes sense, that they used to run on a, self-contained, very controlled environment to provide a specific performance, either functional or non-functional requirements of this component. And now we're moving it to become only software running on the cloud with other components. So we see the challenge here. However, the customer is really targeting here to simplify and save money on moving from special purpose to software and virtualized component. The challenge is how they can do that without impacting the customer experience, and knowing that in the software environment, we upgrade things more often, and that's a challenge, meaning every time you upgrade a component, you actually face the risk that some of the latency, delays, behavior switch over from, in redundancy or in failover state to fast enough to not impact the customer experience. So how we make sure that this transition is done smoothly and it's not impacting customer experience. So in this case, we see the role of service assurance to not necessarily in the context of end-to-end service, but jointly with existing OSS, BSS system, existing system, how we make sure that the virtualized function are still performing and behaving to the same performance that it's as its counterpart in the physical network. And there's so many use cases here where not only to make sure that there are dashboards that show that these functions are running to the spec, but also correlate this behavior to the cloud infrastructure and the NFV environment itself. So to recap on that phase, we're really in a phase where the OSS, BSS stay the same. The only saving is in the transition from a physical to virtualized network, how we do that without impacting the customer experience. So some of the customer strategies to keep the OSS, BSS as is, as a first step, and the service assurance as well interface still works in silo mode, but it is, instead of assuring a end-to-end orchestrated service, it's actually assuring basically functional component that moved from like virtual EPC, like IMS, virtual IMS, like DNS server, and so on, moving from physical to virtual. The next step, where a change in the architecture of the first step of migrating or changing or evolving the SA from SA to next generation SA is to open up the system. And here in this step is to all the function of service assurance need to be opened up in the right way, similar to any VNF function, meaning they are defined in Yang and Tosca format. They are having open APIs that are available for the higher layer. And that will really enable a certain level of automation to start happening here. So you can start developing end-to-end services, not necessarily fully orchestrated and not necessarily fully dynamic, but at least you can automate the process of creating a service chain and assure it in a dynamic and an automated way. Today, even in the physical network, we are involved in EXFO in several automation systems that are automating the process, things like a birth certificate, like assuring the SLA of the system or monitoring. So the automation level is already existing in the physical network. Now, how can we migrate that to the virtualized components as well? And opening up the system is really pave the road to or pave the way to the next step, which is really the final DevOps environment where the whole process will change, the dynamics will change, and how service assurance is embedded in the whole process will change. But the first step, you have to have open API, you have to have openness of the service assurance system, so become more, instead of silos that have very specific function to a very specific operational group, to open API that are available for programmability that can be inherited or enriching a DevOps process. So when we move to the last step, now we have the open API, now we have service assurance function like passive monitoring, active monitoring, and analytic and correlation, SQM. Now it's available as microservices and open API to a DevOps orchestrator where you can do the things that Mark mentioned, things like, creating services quickly and assure them. Being dynamic and agile to changes in the service definition and service chain, adding components, removing components, restricting components. All these dynamics that will happen will require a very dynamic and open service assurance that can be called upon or integrated with not just orchestrator, but also a DevOps dashboard. We envision that DevOps dashboard will actually include both the development of the service, but also the assurance of the service, and need to be integrated in a very user-friendly way, meaning people who are running or building the services, the joint team of development operation, they don't want to know too much of the details of the technology. You just need to know what is available and how can be enriched throughout the process of creating a service in real time. How can be enriched with monitoring services, with testing services, and with correlation services that enable that closed loop SQM or closed loop service quality management, where events happen, they are correlated, they are pushed to the orchestrator, where the orchestrator take a decision to do self-healing or scaling the service or whatever the action might be, not only to do troubleshooting, but what we call a proactive troubleshooting, where you actually find that there are issues that will happen in the network and you have already remedies to do that automated. Of course, it's not going to happen day one. It's going to evolve over time. But we need to provide the open API. We need to provide the architecture that enables this to move from 100% manual process of troubleshooting to gradually to more automated closed loop troubleshooting. If we go or we look at the life cycle of service assurance in a service today. So today, all these steps happening today in today's network. So the architecture, the service is defined. It gets pushed to the engineering team. The engineering team select the network component and network architecture needed to provide the service. They test it in the lab with simulation, and then they push it to the next team where they do limited deployment and do validation. And then after that, it gets pushed to the operation where they actually have the certification and the validation of the service every time it's activated. Then finally, they need several tools to do troubleshooting. So service assurance today is involved in all these steps. It's really involved in a silos approach where each one of these separate groups needs separate tools, and they need to do the validation, the assurance of the service based on the circumstances and the scope of each one of these steps. So what is really the change that will happen going to the DevOps and the next generation service assurance? First is that this whole process is running by a smaller number of teams. And it's not only that, It's also need to be tailored to that specific service. So, for example, if you are monitoring a VIP, high-quality voice service, traditional voice service, you will need a bigger team. You will need more assurance in all the steps. But if you are running a new service that is basically doing an add-on voice service to other service that it's not necessarily require the same heavyweight service assurance, then you will tailor it to that. So that's the first change in this process. Second is the automation part of it. How can you include or provide all these tools from simulation to validation to certification that goes with every time you activate a new component, to finally set of tools that troubleshoot the service to become really part of the Devops dashboard. That's where the innovation is in this area. So here there is a lot of work needs to be done to actually make sure that all these tools are available in the same spot and they can be integrated in a very user-friendly in this life cycle end-to-end. In addition to that, and this is the extended scope of service assurance, is to actually provide the closed loop. And the closed loop will basically correlate monitoring or events in the network in actions that can be pushed to the orchestrator, where the orchestrator have the intelligence to deal with one of these actions. So this is really beyond the existing scope of service assurance that actually comes in the scope of orchestration and the overall DevOps approach. Finally, all these capabilities can be also exported to through a portal or being available through portal in an even more user-friendly way to the end user. So the end user can actually manage the life cycle of the service by adding components, removing components, scaling the service, and the service assurance come automatically part of that. So, for example, a customer is adding, a firewall, as mentioned by Mark. Then once this firewall shows up, then right away he'll get all the set of tests to make sure that his requirement of that firewall is actually working. I will finally just bring one example before I pass to Ansi to focus on to describe our analytics product. The virtual CPE use case is really one of the cases that are very, we see it in the market today. And it's really one of the use cases where service assurance and enabling the end users or end customer to be involved in the process of assuring the service and monitoring it in a very user-friendly way is very important, because two issues with the existing business Ethernet services, for example, is one is the truck roll. Every time you need to add a service, there is a demarcation point. You have to send the truck roll to make sure that the service is working fine. And second is the time to market, or the time that it takes for an order to be processed, to including this truck roll. So the virtual CPE will really enable to push some of this complexity inside the network and make it so simple at the user side to basically install their access, their CPE in a very easy way. But once that is installed, then everything will be available to them through portal. And that means that the end user will be involved in certifying the service, troubleshooting it, or at least doing the simple process of making sure that the service is working fine without doing a phone call and truck roll and all that. Service assurance will be very, very needed in this way to make sure that this agile and agile process is working properly at the lowest cost and the highest customer satisfaction. With that, I will pass the presentation to my colleague Ansi to present our 3D analytic architecture.
Thank you, Ihab. So as we learned from the previous presenters, the analytics will play a key role in the service assurance of virtual and hybrid networks. So in the second part of this presentation, we wanted to be a little bit more concrete and go one level deeper from the theory to describe the key points of our analytics architecture and basically illustrating how we are getting ready for the transformation. So the high-level view of our analytics component is basically illustrated on 3 different layers. So we call this 3D analytics, and the idea is that we are building basically an end-to-end visibility across the whole network. So we are analyzing or collecting the data from 3 main layers. First of all, there's the subscriber information. So we are collecting data from the underlying network and analyzing it from the subscriber perspective. We are collecting information about services. So that means that we are tapping into different data sources and we are using our service and data modeling tools to basically model the service itself. And then we are collecting raw data from the network basically to analyze the performance and the situation of the status of the network. So the concept of 3D analytics can be illustrated on 3 different layers. So we are basically analyzing the user transactions, the mobility data, so the signaling and user plane data, and then the underlying infrastructure, meaning the IP backhaul network and even the physical layer. And the main functionality of the analytics component will be, even in NFV and hybrid networks, it will be mostly the same as it is in physical networks. So the key functionality is to manage the end-to-end service experience. So basically collect the data from different layers and different data sources and combine it together to stitch the end-to-end view. So the task number 1 is the visibility. The second part second key function is troubleshooting. So even or especially in the virtual networks, analytics functionality will be needed for locating and pinpointing the problems. And then the third function is a new one. So this is the automation of service assurance and verification, also called closed loop analytics. And we saw in the previous example that we have presented on how that works in practice. So in order to ensure the full portability for virtual networks, we have defined an agile self-service architecture for the analytics component. And the key points of that platform are universal data connector layer, dynamic data modeling functionality, then the user configurable real-time dashboards and historical reports, user-definable KPIs, and then of course multiple different type of interfaces and APIs to read the data in. And I will show you briefly some examples on how we have implemented this functionality in our platform. So first of all, the overall architecture has been designed to make the system as real-time as possible. So we are talking about few second latency in the fastest case. Some data is being collected at 1-minute interval, and some data which is not so time sensitive is collected with the longer intervals. So basically the data collection is handled by the data collection and adaptation and routing layer, where we have different kind of adapters for active and passive data sources, and we also have discovery functionality. The data processing itself happens in the middle. So we are performing in-memory computing to increase the real-time aspect of the system. So majority of the events will be handled in real time in memory when they arrive to the system. We have a big data warehouse where we are storing the results of the computing, but some of the results are being passed further into rule engine to be further refined and also fed into third-party systems for actions such as service orchestration. On the top, you can see the visualization layer, which is of course important part of the whole analytics. So we can have different kind of findings and different kind of reports visualized for the end users as well. So when moving into virtual network infrastructure, focus will move further into automated interfaces and machine-to-machine interfaces, and that's illustrated by the silo on the right-hand side. So we are there's a number of APIs that we are in progress of implementing, how to feed the data into different kind of systems and how to read the data from multiple different OSS and DSS systems. Now going deeper into key functionality, here's an example of a universal data adapter layer. So basically the end users have a possibility to, or the administrators have a possibility to define new data sources. This is critical because in the future we see that the amount of new network functions and new data sources is going to grow, and in order to increase the agility, it is a must feature for any analytics component to be able to read in the new data. So how that works in practice is that you define, as you can see from the screenshots, in our solution you define the format and the data fetching interval for the source data, and then there is a mapping file, basically how to map the source data into an internal data model. After we have read the data in, we are using our data modeling tool basically to structure the data, and also we use this for calculations and KPI calculations and data summarization. So how it works in practice is that we have different kind of objects. We have physical network objects and we have logical entities here. Basically, the inventory can be read into the database, and with the modeling tool, the different kind of services, as in this example, can be modeled. And basically to map to the physical or the virtual network infrastructure that is in place in the network. So this infrastructure then, the hierarchy is used later on for correlating the data. So we are basically using it for KPI calculations for different services, but we are also using it for root cause associations because the topology contains all pieces of the chain, and it makes it easier to pinpoint the exactly the problematic locations in the network. The last, but not the smallest part of it, is then the KQR calculations and the visualization. So in our solution, in our platform, we have the capability to, or we let the users, end users and administrators to create their own visualization layer. So in the example here, you can see first, on the left-hand side, you can see examples of the dashboards. So for example, you can define your own layouts on how the dashboard should look like. There is a library of ready-made widgets, and so they can be, for example, graphs, or they can be map interfaces. You can define your own KQIs. You can define your own KPIs to be visualized on the map, and you can also define rules and thresholds so that the system will react automatically whenever the rule is fulfilled. The benefit of the architecture is actually quite obvious, I would say. So first of all, the ability to combine the different multiple data sources together and really to stitch them together to have the visibility into whole end-to-end chain will reduce the mean time to resolution. So this helps to to troubleshoot the problematic locations. So it helps to find the problematic areas in the network across all the different layers that we discussed earlier. This increases the agility. So whenever, for example, new services are being created and developed with this type of architecture and approach, we can respond to the needs much faster because no coding or no new features are needed. And of course, letting the end users to do it largely by themselves reduces the total cost of ownership of the solution. So those are the benefits in a nutshell. I think we have used most of our time for the presentation, and now it's time for the questions and answers.
Yes, thank you, Anssi. That was very interesting. We've had several questions in already from the audience, so I would urge you to send in some more because we have a great panel here ready to answer your questions. But I have the first question all ready to go, and that's going to be for EHAB. And the question is, reduction of CapEx and OpEx is great when you have open automation. But to achieve that, automation also requires investment, not just in terms of money, but also in terms of people. That's not an easy thing, and that includes the culture of a company. So how can we achieve that? That's the question, EHAB. Please, can you answer that?
Thank you very much, Mark. It's definitely a big question to answer, and it's the biggest challenge. When we talk to our service provider, our customers, and the cultural transformation in operation is probably the biggest challenge in NFV SDN. It's a huge challenge, and they face the same challenge when they move to IP and packet network. They always face the challenges from operation point of view. But what we see is that it's really the Devops environment and this new way of doing work is going to happen in a catalyst mode, meaning there will be a certain service that will be developed in this way. Instead of people doing manual work forever, there will be investment needed initially to do the automation part. Then automation became part of the culture. So people, instead of doing the monitoring themselves, they will find ways to how to automate this process. This culture is already in the cloud network today and web scale culture, and this is exactly what service provider want to move to. So it will not happen overnight. It's not going to be a big bang. It's going to be basically a snowball effect where you will have one service like virtual CPE, for example, where it makes sense to do the automation and there will be a business case for it. And then that will show the value, then that will start spreading into the culture faster. So I don't have a crystal ball to say exactly how it will evolve, but that's the approach we see our customers are doing.
Okay, thanks very much, EHAB. I've now got a question that I'm going to direct to Mark Mortensen. Mark, the question is, does the service assurance problem really need to be solved before NFV can be implemented?
Yeah, it's a good question, and the answer is kind of no. In the way that, first of all, a lot of the trials are going on without really much service assurance going on, and a lot of the first implementations are going in without very much high level service level information being done. So you can get by the way we got by for many years with basically keeping the piece parts working. Just watch the piece parts and make sure that they individually work. Then chances are the service is going to be working okay. So you don't really need at first blush that service management and service quality management layer, but it's certainly something that the product managers want. It's certainly something that eventually the customers want. But you can get by for a while with just making sure that the piece parts are working down there at the VNF manager level. And if they're not working, then you spin up some new ones, perhaps even manually. So we're not getting this good closed-loop process of bringing things back up very quickly, but you can kind of get by for a while. And I expect an awful lot of the operators are going to get by for a little while until they have a chance to really put in place the proper service assurance system.
Okay, thanks for that, Mark. Looking at, I mean, do you, still on the on a similar topic, do you think that that means all of the service assurance systems need to be replaced?
You know, it's a really interesting question on that. We all looked, when we first started looking at the OSS infrastructure for virtualization, we asked ourselves the question, is this an opportunity to really almost throw away all of the legacy stuff that we have and start off with a whole new paradigm that probably would actually, the whole service assurance would be based on analytics. You know, we've spent an awful lot of money putting together these big telemetry systems and all of these wonderful systems for taking in tremendous number of alarms and sorting through them very quickly in order to determine what the problem is. And we know now that a lot of those problems could be solved with big data analytics techniques by just dumping all of these data into a massive database in core, and then chewing on it using all of the big data analytics techniques today. So we see certainly that it gave an opportunity, we think, to perhaps start over again in service assurance. But we really, because of the hybrid networks are going to be around for a long time, we do believe that there's going to be a lot of the existing service assurance systems watching over the physical part of it, and they'll probably be reusing a lot of the service quality management pieces for the overlooking the virtual parts and the hybrid parts also. So although it's an opportunity perhaps to throw it all away, it's probably not going to be something that's going to be done in very many cases. But if I had to take a guess, I would say in 3 to 5 years we will be talking about major transformation projects. Once you hit a certain critical mass of the network being virtualized, which is probably somewhere around 30 or 40%, I would guess, it might make sense to actually relook at it and take a look and see if you ought to almost start over again and kind of do it, I wouldn't say right this time, I'd say do it better this time.
Okay, thanks very much, Mark. We've got another question in, and this one I'm going to direct to Ansi. And it picks up straight after our poll earlier, actually, which was looking at the comprehensiveness of the solutions on offer. So the question is, which pieces of the service assurance puzzle are still missing for hybrid environment service assurance? And what confidence do you have that all the necessary parts will be ready in time? Ansi, over to you.
Thank you, George. So at least 2 things come to my mind right away. First of all, the data collection part. So one of the key data sources for service assurance is passive monitoring. So basically the collection of individual CDRs and XDRs, so individual subscriber events from the network. Today it's mainly done by, or it's almost entirely done with the dedicated hardware probes, and assumingly in the NFV, it will be done mostly with software probes. Now, we're talking about huge volumes of data and a huge quantity of CDRs and XDRs, and the interfaces don't quite support those yet. So full software probing or passive monitoring with software probes is not really possible today. Hopefully it will be resolved soon. So this is one part that is missing, but of course there are already first products out there, and the capacity of the network interfaces or the software interfaces is improving all the time. So I think it will be solved quite soon. The second part that is missing, of course, is the whole service orchestration architecture, or I would say the ecosystems. So I think there will be multiple different implementations of the service orchestration, and it is quite not clear yet that how the closed loop analytics will work in cooperation with different type of ecosystems. So without a doubt, this is a problem which can be solved as well, and I think this is whether they will be ready in time is a chicken and egg question, because I don't think any NFV networks will be ready before this functionality is implemented. So
Sorry, Ansi. I was just thinking, when it comes to saying in time, time's such an elastic concept when it comes to the chicken and egg of NFV that it's hard to jump on a definition for what in time means, because it will mean different things to different operators.
Right. So those are the two things that come to my mind, at least with few minutes of thinking.
Okay, thanks, Nancy. Mark, we've had a question in directly for you, which is, don't you think that the real value of SDN and NFV will be delivered once the dynamic components of OSS BSS are available, such as the ability to build for dynamic products? Won't getting by be a risky thing to do because it could result in revenue loss? Mark?
Oh, there's no doubt in my mind that the business case for NFV does not turn positive until you have all the OSS BSS problems solved and you actually are automating a lot of this. So the getting by will be uneconomic. There's no doubt in my mind it will be uneconomic. In fact, we've run the numbers. About 2 years ago, Glenn Ragunan and I ran the first business case on this virtualization, and we were shocked to see that it basically ran out as a negative. And we said, wow, well, we've got a real problem on our hands here. Basically, because you have to buy a whole new sorts of, even though the hardware is cheaper, you have to buy all kinds of new software there for the virtualization layer, which negated most of the benefits. And it wasn't until you really had the operational benefits that the business case flipped positive. And then it really becomes positive when you add the agility. So in fact, if you ask most operators even today, why are you doing virtualization? They will not tell you it's to save money. They will tell you it's to pick up the agility that we think we need to implement new services of the future. So I absolutely agree, by the way. The business case is lousy while you're still getting by. But you can get by for a little while at least.
Okay, great. Thanks, Mark. Got a question in now for Ansi again. Ansi, the question is, what is the trigger for operators to have to deploy new service assurance based on analytics? Is it only the critical mass of virtualization, or could other things be that trigger? Ansi?
Well, I would start by saying that the virtualization is not the only use to move into analytics. So I think that's a global phenomenon we've already seen in the physical networks. So analytics is being used already in service assurance for many different use cases. I would say mostly in analyzing the network and service experience and root cause analysis. Now, there are two drivers in the NFV that are again increasing the importance of the analytics, and those came up also in Mark's presentation. So first one is the real time, increased need for real time. So things need to happen faster, and that's not possible with more traditional OSS systems. And the second part is the automation. So there's a higher number of things that can be run fully autonomously and in an automated manner, and analytics component is really needed to be the brains to guide the actions and have the kind of the knowledge on how to react to certain phenomena or certain events.
Okay, great, thank you. I think we may have time for just one more question, which actually there's a question that I'd like to ask. I'm not sure who's going to be best placed to answer it, but my question is about standardization and how necessary the completion of standardization work is to enable the industry to achieve service assurance in hybrid environments. And I'm wondering about A, the importance of standardization, and B, whether we can afford to wait for standards to happen. I think it's pretty clear now that standards are going to take several more years to develop, and some operators, particularly the fast deployers like AT&T, aren't going to wait around for standards to be developed. So I'll put that question first to Ehab. Ehab, do you think completion of standardization work is necessary to enable the industry to achieve service assurance in hybrid environments?
I think partially. I think the new culture is to a joint of open source joint development and cooperation and standards. They all work together. So some example is the core activity in the own lab. It's basically developing a reference architecture to how the new re-architected central office, and they're basically developing the reference architecture jointly with service providers and vendors. Now they're also working very closely in tandem with the NFV organization for the core E or the core enterprise for the virtual CPU use case. So I see this as really as a culture where they both feed each other. The making the fact on the ground by developing reference architecture and developing the standard and developing the standard at the same time. So it will make things happen faster, more practical, and actually helping everybody.
Great. Thanks very much, Ihab. I'm afraid we've now reached the end of today's Vanilla Plus webinar, so I'd like to take this opportunity to thank our panel, and Anssi Tariainen, the Director of Business Development at EXFO, Ihab Manna, the Solution Architect at EXFO, and last but not least, Mark Mortensen, the Lead Analyst of Analysys Mason. Thank you all very much for your participation, and thanks also to the audience for joining us today. Goodbye.
Thank you.
Thank you. Bye-bye.
Thank you.